The year 2049 might seem distant, but it's a crucial marker in our fight against climate change. The choices we make today will determine the state of our planet in 2049. Our current crisis began with the Industrial Revolution. This period of rapid technological advancement, starting in the late 18th century, ushered in an era of unprecedented fossil fuel consumption. Coal-powered factories, steam engines, and later gasoline-powered vehicles released massive amounts of carbon dioxide and other greenhouse gases into the atmosphere. These emissions began to accumulate, trapping heat and altering the Earth's climate system. The science is clear. The planet is warming at an alarming rate, and human activity is the dominant cause. From the melting glaciers of Greenland to the intensifying hurricanes in the Caribbean, the evidence of a changing climate is undeniable. The question is, can we change our course before it's too late? Understanding the mechanics of climate change is crucial to grasping the gravity of the situation. The Earth's atmosphere acts like a greenhouse, allowing sunlight to pass through and warm the surface. Naturally occurring greenhouse gases such as carbon dioxide, methane, and water vapor trap some of the outgoing heat, keeping the planet at a habitable temperature. However, human activities, primarily the burning of fossil fuels, have dramatically increased the concentration of greenhouse gases in the atmosphere. This excess of greenhouse gases traps more heat, leading to a gradual warming of the planet, much like a greenhouse traps heat to foster plant growth. The consequences of this enhanced greenhouse effect are far-reaching and increasingly evident. The increased heat is altering weather patterns, leading to more frequent and intense heat waves, droughts, and wildfires. The oceans are absorbing much of the excess heat and carbon dioxide, leading to ocean acidification, which harms marine ecosystems and the livelihoods of people who depend on them. The evidence of climate change is no longer subtle. It's staring us in the face. Extreme weather events, once rare occurrences, are becoming increasingly common and severe. Heat waves are scorching cities across the globe, pushing temperatures to unprecedented levels and straining power grids. Droughts are parching farmlands, leading to crop failures and food shortages. Wildfires are raging with greater intensity and frequency, fueled by hotter temperatures and drier conditions. These fires are not only destroying vast swaths of forest, but also releasing massive amounts of carbon dioxide into the atmosphere, further exacerbating climate change. Coastal communities are facing an existential threat from rising seas, with low-lying islands and coastal cities at risk of being submerged. The impacts of climate change are not evenly distributed, with developing countries disproportionately vulnerable. The consequences of climate change extend far beyond environmental damage. The economic costs are already being felt around the world, and they are projected to escalate dramatically if we fail to act decisively. Extreme weather events are causing billions of dollars in damage to infrastructure, crops, and property. The World Bank estimates that climate change could push more than 100 million people into poverty by 2030. The poorest and most vulnerable populations are the most at risk, as they are often the least equipped to cope with the impacts of a changing climate. Beyond the economic costs, climate change poses significant risks to human health and well-being. Heat waves can lead to heat stroke and other heat-related illnesses. Droughts can contribute to malnutrition and waterborne diseases. Climate change is also expected to increase the range of disease-carrying insects, potentially leading to outbreaks of diseases such as malaria and dengue fever. The displacement of millions of people due to rising sea levels or extreme weather events could lead to social unrest and political instability. Faced with the daunting reality of climate change, some scientists and policymakers are exploring large-scale technological interventions to cool the planet, collectively known as geoengineering. These technologies aim to manipulate Earth's climate system to counteract the effects of greenhouse gas emissions. One proposed geoengineering method is solar radiation management, or SRM, which aims to reflect a small percentage of sunlight back into space to reduce the amount of solar energy reaching Earth. This could be achieved by injecting reflective particles into the stratosphere, mimicking the cooling effects of volcanic eruptions. While SRM could potentially lower global temperatures, it does not address the root cause of climate change: greenhouse gas emissions. Another geoengineering approach is carbon dioxide removal, or CDR, which focuses on removing carbon dioxide from the atmosphere and storing it underground or in other long-term reservoirs. CDR methods include afforestation, reforestation, bioenergy with carbon capture and storage, known as BX, and direct air capture, or DAC. While CDR addresses the root cause of the problem, these technologies are still in their early stages of development and face significant technical, economic, and ethical challenges. The potential benefits of geoengineering are alluring, offering a possible lifeline in the face of a changing climate. However, the risks and uncertainties associated with geoengineering are substantial, and the long-term effects on the planet's complex climate system are largely unknown. The allure of a quick fix to climate change is understandable, but the potential consequences of geoengineering are too significant to ignore. Tampering with a complex system like Earth's climate could have unforeseen and potentially catastrophic consequences. Injecting reflective particles into the stratosphere to block sunlight could disrupt regional weather patterns, potentially leading to droughts in some areas and floods in others. Furthermore, relying on geoengineering as a solution to climate change could lead to a phenomenon known as moral hazard. If we believe that we have a technological fix for climate change, we may be less likely to reduce our greenhouse gas emissions, potentially exacerbating the problem in the long run. The international community needs to establish clear guidelines and regulations for geoengineering research and deployment to prevent misuse and ensure that these technologies are used responsibly, if at all. While geoengineering might seem like a tempting solution, it's crucial to remember that it's merely a band-aid, not a cure. The only sustainable way to address climate change is to drastically reduce our reliance on fossil fuels and transition to a clean energy future. This transition requires a fundamental shift in our energy systems, moving away from polluting fossil fuels towards renewable sources like solar, wind, geothermal, and hydropower. Fortunately, the renewable energy revolution is already underway. The cost of renewable energy technologies has plummeted in recent years, making them increasingly competitive with fossil fuels. Solar and wind power, in particular, have experienced exponential growth, with installations breaking records year after year. As these technologies continue to mature and become more efficient, they are poised to play a central role in the global energy mix. Beyond technological advancements, we need supportive policies and investments to accelerate the renewable energy transition. Climate change is a global problem that requires a global solution. No single country can solve this challenge alone. The Paris Agreement, adopted in 2015, was a historic step forward, uniting nearly 200 countries in a commitment to limit global warming to well below 2 degrees Celsius, preferably to 1.5 degrees Celsius compared to pre-industrial levels. However, the commitments made under the Paris Agreement are not yet sufficient to avert dangerous climate change. Developed countries, which bear a historical responsibility for the majority of greenhouse gas emissions, have a moral obligation to support developing countries in their mitigation and adaptation efforts. Financial assistance, technology transfer, and capacity building are crucial to enabling developing countries to leapfrog to clean energy technologies and build resilience to the impacts of climate change. Beyond government action, businesses, investors, and individuals all have a role to play in tackling climate change. Individuals can make a difference by reducing their own carbon footprint through lifestyle changes, such as consuming less energy, driving less, and adopting a more plant-based diet. The year 2049 is not that far off. The decisions we make today will determine the kind of world we leave for future generations. Will it be a world ravaged by climate change where extreme weather events are the norm? Sea levels have inundated coastal cities and millions are displaced from their homes? Or will it be a world where we have successfully transitioned to a clean energy future, where the air is clean, the environment is healthy, and the planet is on a path to recovery? The choice is ours. We have the knowledge, the technology, and the resources to avert the worst impacts of climate change and create a sustainable future. What we need now is the political will, the collective action, and the unwavering commitment to make it happen. Our children and grandchildren are depending on us. Let us not fail them.